Hello, people. How y'all doing? Today we are going to be doing some bubble sort. So what I'm going to be doing is I'm going to be doing a couple videos. I'm going to do a video for bubble sort. I'm going to do a video for selection, insertion, merge, quick count, heap. We're not going to cover for this midterm. And we're going to be doing hash maps and recursion and tail recursion as well as backtracking. Okay, so it's going to be a video for each except recursions. I might just blend them all into one lecture. So yeah, the first three videos, bubble, selection, and insertion, these are the hardest ones. Oh, sorry, the easiest ones. So if you get any questions about these, it should be free marks. Should be. But anyways, so this is boilerplate code. I'll run through it really quickly. I have one function that will just generate a random array. So you see, I just use the random. I create like my inputs is the size, minimum number, maximum number. And I generate random numbers. I create the array with the size, make a for loop, fill the array out, and return the array. In my main, this is the size, so if I want values between 100 and whatever, I'll just change them here and it will create an array within these numbers. This right here is just a for loop that will go through the array and print it out. And this one is a for loop, but it calls a function called bubble sort. So this is a for loop that will go, you see this function will return an array. So I'm gonna go through each index of the array and print it out. That's what this one does. And this is the function. I'm just returning a random array. Just for now, it's just boilerplate. First, we're going to go through conceptual. So a bubble sort, what happens is every iteration it does, every time. So first, let's say it starts at I. So we're going to start I at the end. Okay. Then we're going to have another letter called J. We're going to go through this way. So we're going to be moving that way. And then whenever we find two numbers where one is greater than the other, we swap them. So you see 7 is greater than 2, we swap. 7 is 7 greater than 9? No. We leave it, but we don't go back and reiterate. We will keep going, but we leave the 7 now. We go to the 9. And then is 9 compared to 6? Yes or no? Yes. And then as you can see, after each iteration, the largest number will be complete. So this will be complete. Therefore, I will move closer. That's J. I will move closer now, and it will go away from here. And then now 7 is going to keep swapping. 7 will become here, and this will be in the right position, and so on. Okay, so let's put it into code. So we know first we want to loop backwards, right? And so usually the way you think about it is the letter that only loops once is on the outside, and the letter that loops multiple times is on the inside. And so you see I will loop through the array one time. However, J will loop and then we'll go back, and then we'll loop and then we'll go back. So now we know I is on the outside and then J is on the inside. So we're gonna create a function. So I now we want I to be at the end of the list. So equals the array dot length, but array dot length doesn't give you the array in an index, so it doesn't start from 0, it starts from 1. So the way it will work, we'll give you this as 1, 2, 3, 4, 5. But keep in mind, when I do array and I give it I, right? The first index is not 1. The first index is actually 0. So we want the length of I. And so back here. So if this is 0, then this is 1, 2, 3, 4. So you see, if I want I to be at the last one, then I don't make I 5, I make I 4. And so here, what we'll be doing is the length minus 1. So instead of 5, we do 4. And then after this, we're going to say I is more than 0. So as long as I is more than 0, keep iterating. Because we're going backwards, right? So we're going to go here, minus 1, it's going to be 3, minus 1, it's going to be 2, minus 1, it's going to be 1, and then when 0, then it will stop. And why do we stop at 0 and not equals? Is because once I gets to this position, there's nothing to swap, right? So you don't need to iterate over that anymore. Okay? And then I minus minus, because we're going backwards. And so that's the beginning of your for loop. Now it's giving me that underline because I'm not returning anything. So we'll return a random array just so we get rid of the error, and then we'll fix that after. So now that we're iterating backwards, let's now have the j iterate forwards. So we're going to start another for loop, j. And what do we want j to be? Well, we want j to start at 0, right? And then I want, where do I want my j to stop? My j has to stop at I. Because as you can see, the last one, when 9 is at the current position, j shouldn't go to it. That's where I is at. So as long as j is less than I, then keep iterating. And then once it gets to I, stop. There's nothing else to go to. So as long as j is less than I, keep going. Okay? And then we're going to do j plus plus. All right. Now inside here, what do we want to do? We want an if statement, right? Because if one number is bigger than the other, swap them. So if, which two numbers we want? We want to swap where j's at and with the one after j. So if array at j is, what do we want? Do we want it bigger or do we want it smaller? This is where you choose whether you want it ascending or descending. So here, first let me write it out. So right now I'm comparing the j to the one after it. And I'm saying, is this less than this? If not, swap them, right? That's what we're doing. If I say, is this bigger than this? That will be yes. So it doesn't swap them. And that's when you have from big to small. So right now we're going to go from small to big because I'm saying, is this smaller than this? If it's not, switch them, right? I'm saying, is this number smaller than this number? If it's not, switch. Right? So that's how it goes here. Why can't I undo? Weird. Let me get rid of all the arrows. And so, back to code. Is it? Then switch. How do you switch? First, we want a temporary variable. So int temp equals array at j. This doesn't matter. You could say, you can make the temporary j plus 1 or just j. But you have to switch the one after with the one you didn't put. So if I put j to be the temporary, then I will switch j. Because if I don't switch j, then why do I put it as a temporary? It's not like I'm losing it. So since I put in a temporary, that means I can lose it. So I'm going to replace it with j plus 1. So what I did here, so if j was here, if this was j, then what I said j plus 1 equals j. So then this becomes 2. That means I have to make the 2 the 7. Well, what's my 7? It's the temporary variable I saved. So then I'm going to say, okay, then array at j equals temp. And just like that, I switched it. All right. Now this will work. However, actually, here, let's run it and see if it does work. Return, so this happens, and then we're going to return the array. So let's run this. Yeah, so as you can see, it does work. We have 46, 41, 38, 37, 30, 25, 23, blah, blah, blah. And you see if I switch this to bigger, then it goes descending, or is it ascending? I think it's descending. All right. So now there's one issue about this that you don't really see. It's a logic error. Well, it's not really an error. It's an inefficiency. Is that how do you know when it's already sorted, right? Like how do I know that it's already sorted? So if j loops through the array, right, like just like here, and it doesn't switch anything, if this if statement never runs, that means there's nothing to switch, which means it's sorted, right? And so what I'm going to do up here, I'll start a boolean called swapped, and I'll make it false. This is within the loop, because after every loop, because look, if this loop runs once, and within that one run, this sorts it, then you gotta know if it's sorted within that one run. if I set this here, if I set it outside, right, and I don't set it in here, so this is assuming this never runs, right? So if this runs, it runs. If it's swapped, so swapped equals true. I'll explain what I'm doing. So what's happening here? When the for loop runs and it swaps something, that means we know that it's not what do you call it? Ordered. It's not sorted yet. Okay? So if this runs to be true, that means we just changed something, which means it's not sorted. It might be sorted, but I know it's not sorted yet. Okay? So what happens is, let's say this runs once. Okay? Then the loop goes back for the for loop and it checks. Okay, is it swapped? Right, so let's say here we will check if not swapped, break. So what am I doing here? I'm saying, so when this loop runs, which then triggers this loop, right? J will run through the whole array. It will run, like J will run through within one loop, within this one loop. If it never swaps, after it finishes this for loop, if it never swaps, that means it's sorted. And so here I'm checking if, because remember, swapped is false. So if it's false, means it never swapped. Remember, not false makes it true. That's because I want the if statement to run. But if this is false, I want to break, because that means it never swapped. All right, now why do I want to set this in here? Because if this runs, and then this runs, okay, the first loop, it scans it, it swaps something. So then it goes here. Is it swapped or is it not swapped? Well, then it's going to be true. This is going to be true, therefore this is going to be false. And so this will never run because we did swap something. Then it will go back again, but I'm never switching this. Like, what if in this second loop, now it's sorted and this never runs? How do I know that? That's why I put this in here. I hope that kind of makes sense. Okay? What I want to keep track is, am I swapping anything? When I do this one full sweep of the whole array, did I swap anything? If I don't, that means it's sorted. And that's why I said it here, because after every loop is done, I gotta check if it's sorted. And that's about it. So you see now when I run it, now it still runs the same. You won't really be able to tell, but it does make a difference in terms of efficiency, is that you leave early. So you don't have to, take I here, and then take I here, and then take I here. Maybe when I gets to here, the list gets sorted, and you should exit. But if you don't have the swapped, the for loop will never break, and it will keep going until I reaches here, which you're just doing extra steps for no reason. Okay? And so again, if you want to switch it, like ascending or descending, you just change this one little thing, and as you see, it changes the ascending right here. All right, boys. So that's about it for sorted. I hope that helps. Next thing we're going to be doing is selection. One thing is, you should know for the midterm, and you will probably ask this, what is the time complexity of bubble sort? It is O of n squared. Now, I don't want you guys to memorize this, because memorizing, you are prone to forgetting. But understanding, you will never be prone to not understanding something you've already understood. All right? Maybe you'll forget the way to do it, but you won't forget the thought process, which is the most important thing when it comes to code. And so why is this O n squared? Is, as you can see, I have two loops. Whenever you have two loops, it's O n squared. All right? Because O n squared, the graph for it, so if it's linear, right? If it's linear, that means it's one loop. I only have one for loop that will go through the whole array. You see, I'll go one, and then up, and then second one, third, fourth, fifth, right? That's how it goes. So that is, I don't know why I've clicked that. That is a linear, which is O of n, right? Now, O n squared is exponential. That's how it looks. Now, why does it look like that? Is because as size increases, you do extra loops. So for every one loop I do, for every extra one loop I do, I will be doing, so how would I say this? If the size, I need more numbers. If the size is 10, for every one extra loop I do, I'll actually add 11 more. Because every loop I do, so if the size was 10, in the first loop, I'm going to be looping 10 times because I'm going to be going through the whole array, right? And then so second loop, I will go another 10 times, so now it's 20, and then 30, and now I have 100. And then if I add one more loop, now I'll do 110. I'm not going to do 101. And that's why it's exponential, because when it increases by a lot. Now, when I add one more to the size, so here, we'll say loop count, number of loops, right? So at 10, I'm going to show you guys the problem with this. So at 10, I will do 100. If I add 1 here, which is going to make this equal to 11, then I'm going to be doing 11 squared, which is, I'm not even sure what that is. 11, isn't that 121? Yeah, I don't know why I glitched there. So you see, I didn't even add 10, I added 121. And then if I add another one, which is 12, it becomes 144. You see, if every time you add something, it increments by a constant amount, that means it's linear, okay? So you see, this is not adding in a constant amount. 10 minus 121, 100 minus 121 is 21. 121 minus 144 is 23. So as you can see, is it 123? Am I tripping? Yeah, it is 23. So you see the difference here is 23, and the difference here is 21. And you see, as you increment, this is not constant anymore. That's what tells you it's not linear. Because remember, linear is constant. The number here will stay the same. Okay, so keep that in mind. If it's different, that means it's O of n2. And that's about it for bubble. I'll only explain it once because this will apply the same way to selection, and this will apply the same thing to insertion. All right, and I'll see you guys in the next video.